This is the last topic of electrostatics, and that is the image problem. So let us first define this problem. Consider this is xy plane, z direction, and we have it's an infinite grounded conducting sheet. Let us assume this potential is 0. So it's a infinite grounded conducting sheet. In xy plane, that is at z is equal to 0. So for this plane, z is equal to 0. And a charge q, this charge is q, that is placed d distance above the grounded conducting sheet. Charge q is d distance above the grounded conducting sheet. And we have some point P above the sheet, x, y, z. Consider this point P. So we have to find, first we have to find what will be potential at point P. So in this problem, we have to find, let us see this point P is xyz. So we have to define potential V in a region z greater than 0 at point P. We have to write potential P. Then we have to see what will be force experienced by charge Q. What will be force experienced by charge Q. And in third part, you have to find work done in placing charge Q at point 0, 0 D. So this is the problem. Now in this case, you can see in XY plane, you have infinite grounded conducting sheet. And charge Q is placed above the sheet. So due to this charge Q, charge will be induced on the conducting sheet. So you don't know what is the charge induced and where that charge will induce. So in this case, you cannot directly find the potential, force and work done. So we have to use some trick so that you can easily write the potential and force and work done. And what is that trick? In this problem, we can define the initial condition. Condition is given that in this case, you can see at z is equal to 0, potential is 0. This is given. You can see in xy plane, it's a grounded conducting sheet. So at z is equal to potential is 0. And also far away from the charge distribution, potential will be, potential tends to 0. We can easily see potential in a region, you will see when x square plus y square plus z square is far, far greater than d square. In this region, V tends to 0. Far away from the charge distribution, potential is 0. So we can use these two initial condition on potential, that in xy plane potential will be 0, and far away from the charge distribution potential tends to 0. So in this approximation, now we will draw equivalent problem. So what will be equivalent problem? Let us replace the conducting sheet. So this is plus q charge. Let's take it as plus q charge, and this is at 0,0 d. Now replace the conducting sheet and consider minus q charge at same distance d. So this coordinate will be 0, 0, minus d. And you have point P here. Let us take this point P is xyz. And then write the potential at this point. Let us take it as r plus, and this is r minus. These two are equivalent problem. Now it's a case of 2-point charge. We have replaced this. You have plus q charge, minus q charge. What will be potential in xy plane? You can see due to plus q and minus q, because we have taken at same distance d. So potential in xy plane will be always 0. And you will also see far away from the charge distribution potential tends to 0. So this condition is satisfies. So in that sense, these two are equivalent problem. So using this trick, we can find the potential. So you can see if it is plus q charge, we call this minus q charge as a image charge. If this is minus q charge, image charge will be plus q. And they will develop in such a way potential in xy plane must be 0. Now we can easily write the potential in this case.
Sir?
Yes.
So can you please explain how the second condition is being
Then let's write down
fulfilled in this?
You know that whenever you have 2-point charge, far away from the charge, potential will tend to 0 because it is inversely proportional to r. So when r tends to infinity, potential tends to 0. That you know, potential is inversely proportional to distance. So far away from the charge distribution, potential tends to 0 in this case also. That you know.
So that is a general case which we are taking, and that would be valid for this one also.
That will be valid for this case also.
Okay.
So we can write potential as the function of x, y, z. So that will be given by, let's take 1 by 4 pi epsilon naught common. So this is plus q by r plus, and this is minus q by r minus. Simply potential due to 2-point charge. Now it's a case of point charge, and you can easily solve the case of point charge. So we can write potential as x, y, z can be written as 1. Let's take q common. So q by 4 pi epsilon naught. And what will be 1 by r plus? Just see, this is x square plus y square plus z minus d whole square, and minus under root, you can see x square plus y square plus z plus d whole square. This is the potential. You can easily write r plus will be this distance. So x minus 0 whole square, y minus 0, z minus d. In this case, this is minus d, so you will get z plus d whole square. This is the potential in a region z greater than 0. Now you can see again, if you put in this expression, if you put z is equal to 0, potential will be 0. And you will see if x square, y square plus z square is far, far greater than d square, in that limit also v tends to 0. So this is the potential. This is the potential. And that potential is potential at point P. So actual problem is you have a conductor and a charge q, what will be potential at point P? So that potential we have calculated using this trick. Now, if you know potential, we can calculate the surface charge density induced on the conductor. We have discussed the boundary condition that whenever you have a conductor, an outside conductor potential is given, and you have to find what will be surface charge density induced on the conductor. So we can find charge density sigma induced on the conducting sheet, that will be given by sigma is normal derivative minus epsilon naught del v by del z at z is equal to 0. In this case, because sheet is in xy plane, so normal derivative is with respect to z and interface is at z is equal to 0. So you will get surface charge density induced on the conducting sheet. So let us calculate this. What will be charge density induced on the conducting sheet? So just differentiate. So we can find, in this case, sigma is given by, if you multiply with minus epsilon naught, this is minus q by 4 pi. And what will be del v by del z? This will give you minus of 1 by 2 x square plus y square plus z minus d whole square power minus 3 by 2, and then differentiate with respect to z, so you will get twice z minus of d, and second term will give you plus 1 by 2 again x square plus y square plus z plus d whole square into twice z plus d, and finally you have to put z is equal to 0. So just see, if you put z is equal to 0, so this will be minus of, this 2 will cancel out, z is 0, so this will be plus, this is also plus, so sigma will be given by minus of,
Sir, whole power of, sir, whole
minus 3 by 2 all the whole power.
this will be, here you have whole power of 3 by 2, minus of 3 pi by 2, this will be minus of 3 pi by 2, and then 2 into z plus d. So if you add these two, you will get 2q by x square plus y square power 3 by 2. This is minus of 2d, not q, this is 2d. So finally this will give you minus of qd.
Sir, there is a d square term also in the 3 by 2 power.
No, x square plus y square plus d square. Yes, you have d square. This term is x square plus y square plus d square power 3 by 2. So this will be minus qd by 2 pi x square plus y square plus d square. Now you can see this sigma is function of xy. Just see, this is the surface charge density induced on the conducting sheet, and that is function of xy. This will vary as xy. So if you know surface charge density, you can find what will be total charge induced on the conducting sheet. So what will be total charge induced? That will be given by sigma dA, and this is an infinite sheet. So we can easily write this in cylindrical coordinate. So in cylindrical coordinate, let us take x square plus y square is r square. So you can write this as minus qd by 2 pi r square plus d square. This will be 3 by 2. R square plus d square power 3 by 2. And this is r dr d phi. And what will be limit of r? R you can take 0 to infinity because it's an infinite sheet. And phi will be 0 to 2 pi. So calculate this integral. Just calculate this integral. You will see d phi will give you 2 pi. So 2 pi will cancel out. Minus q d will be common. So take r square plus d square is t square. Calculate this integral. If you calculate this integral, you will get this is minus q. So total charge induced will be minus q. You can easily integrate. Integral r square plus d square power 3 by 2 here r dr. So you can take another variable r square plus d square is t square. You will get total charge on the conducting sheet is minus q. Is it clear? Now we will see force experienced by what will be net force between charge q and the grounded conducting sheet. So that is the case of 2-point charge. So we can simply find the what will be force experienced by plus q charge. So this plus q charge is attracted towards the minus q charge. It means there will be net attraction between charge q and the conducting sheet. So this force is given by, you have 1 by 4 pi epsilon naught. You will get q square by 2d whole square and direction will be minus z cap. This is the force experienced by charge q and the conducting sheet. That is simply force between 2-point charge plus q and minus q. So there will be net attraction between charge q and the conducting sheet. So that is second part, force experienced by charge q. Now what will be work done in placing charge q at this point? So you have to remember this point. You don't have to write electrostatic energy of these 2-point charge, because you have to find the work done in placing charge q near this conductor. So you will see that work done will be half of the electrostatic energy of this case. How you will calculate work done? You will get infinity to d f dot dl. Use this relation. And dl is along z direction. So we can write, and this work done will be always negative because charge is attracted towards the conductor. So work done will be always negative. So this is infinity to d 1 by 4 pi epsilon naught q square by 4z square dz. I have written in terms of variable z along z axis, and if you this is infinity to d, and if you calculate this value, you will get minus 1 by 4 pi epsilon naught q square by 4d. This is the work done in placing charge q at point 00d. If you see electrostatic energy of these 2-point charge, electrostatic energy will be 1 by, you will get minus 1 by 4 pi epsilon naught q square by 2d. So must remember this point. You don't have to write electrostatic energy of 2-point charge. You will see here term is 4d. So always use infinity to d f dot dl, because it's a conductor, and if you place in the upper half, I am focusing on upper half only. So there will be no contribution from lower half in this case. So that's why work done in placing charge q near the conductor is half of this case. Please remember this point. If you have case of point charge, work done will be q square by 2d, but it's a conductor and you have contribution in the upper half plane only. So that's why work done is minus 1 by 4 pi epsilon 0 q square by 4d. So just remember this point.
Sir,
So you can easily find the force experienced by plus q charge. So you have equivalent problem. You can easily find. Similarly, you can find force on minus 2q charge also. Let us find force on minus 2q charge. In the same problem, what will be force on minus 2q charge? What will be force on minus 2q charge? Let us calculate this. Force on minus 2q charge. So in this case, again, you have to see force on minus 2q charge. So if you find force due to plus q, this charge will be attracted upward. Force due to this will be F plus 2q, and force due to minus q, this will be F minus q. Then you have to see the resultant force. So F plus q is given by 1 by 4 pi epsilon 0. This will be q into 2q by 2d whole square. Then F minus q is, F minus q will be q into q by 6d whole square. Then we will see resultant of these two. And F plus 2q is given by, what will be F plus 2q? F plus 2q is 4d. So 1 by 4 pi epsilon 0 q. This will be, this is 2q. In each case, you have to write 2q into q. Here you will get 2q into q. Then you have 2q into 2q, and this will be 2d. This will be 2d whole square. So force on minus 2q due to plus q, 2d whole square. Then due to minus q, this will be 4d. This is 4d. Just take it as 4d, and this will be 2d. So what will be resultant of F plus q minus q? Q square by 4 pi epsilon 0 d square. Q square by 4 pi epsilon 0 d square. And then you will get 2 by 4 plus 2 by 16, resultant of these two. So this will give you F plus q minus q is q square by 4 pi epsilon 0 d square, multiply by 4, 10 by 16. Is it clear? 10 by 16, because this is 2 by 4 and this is 2 by 16. Multiply with 4, 10 by 16. And this is the resultant of these two force, that will be upward. F plus 2q is q square by 4 pi epsilon 0 d square. This is 4 into 4, this will be 1. 4 into 4 is 1. So what will be resultant force? F plus 2q minus of F plus q minus q. So q square by 4 pi epsilon 0 d square. This will be 1 minus 10 by 16. Force is downward. So this is q square by 4 pi epsilon 0 d square. And 16 minus 10 is 6 by 16. This is the resultant force, and this force will be downward. So again, in this case, this force is attracted towards the conductor. Is it clear? Now we will see next example. Now let us consider you have a conducting sheet that are placed perpendicular to each other along x and y direction, and it's a grounded conducting sheet. Charge q is symmetrically placed at point AA. This is the origin. What will be force experienced by charge q? We have to find force experienced by charge q. These are the grounded conducting sheet and they are placed perpendicular. You have a grounded conducting sheet again. We have to draw its equivalent problem. So in this case, you will see let us replace the conducting sheet. This is plus q charge. Now you will see there will be 3 image charge. This is minus q, then this will be plus q, and you have another charge minus q. This is the equivalent problem. In this case, you will get 3 image charge. Only then potential on the xy plane must be 0. In this case, you will get 3 image charges. And they are at same distance AA here. This is also AA. Now it's a case of 4-point charge. Just see on this, if you see any point, potential must be 0, because at this point minus q plus q, they are same distance, plus q minus q, so they will cancel each other. So at any point on x and y axis, potential must be 0. And then we can find force on this charge due to 3 other charge. So let us see, force due to minus q is, this is the direction. This is force minus q. Similarly, this force is also F minus q. And we will get force due to plus q in this direction. This is force F plus q. No, this force is outward direction because this is the plus q charge. So this force is F plus q. So we can easily write magnitude of force F minus q. So both case mod F minus q is 1 by 4 pi epsilon naught q into q by 2a whole square. And what will be this distance? This whole distance is, let us take this distance is small r. So this r is given by under root 4a square plus 4a square. So that will be 2 root 2a. So force plus q is given by, force due to plus q is 1 by 4 pi epsilon 0 q into q by 2 root 2a whole square. So this will be give you 1 by 4 pi epsilon 0 q square by 8a square. Now what will be resultant of these two force F minus q minus q? That will be in this direction. F minus q minus q. So let us find the resultant force. F minus q minus q. So that will be under root 2 times of F minus of q. Because they are perpendicular, so under root F minus q square plus under root F minus q square. So that is root 2 of F minus q square. So you will get 1 by 4 pi epsilon naught under root 2 q square by 4a square. So now what will be resultant? You will see F minus Q is greater. So resultant force is F minus Q minus of F plus Q. So this will be Q square by 4 pi epsilon naught A square common under root 2 by 4 and minus of F plus minus of 1 minus 8, or you can write this as Q square by 32 pi epsilon naught A square. Take 8, multiply with 2, so you will get 2 root 2 minus 1, and this force is towards the corner. This is the force experienced by plus Q charge, and this force is towards the corner. Now we will generalize this case. In this case, I have shown you that when they are at right angle, image charge will, 3 image charge will develop. Let's see what will happen when they are at some angle. Sometimes in objective question, they will ask you how many image charge will develop, so that you can calculate. So let us generalize this case. Now you have a conductors. This is one conductor. This is another conductor. This angle is theta, and charge Q is symmetrically placed. Charge Q is symmetrically placed, and this potential is 0. Charge Q is symmetrically placed. You have to see how many image charge will develop. This is the general case. So in this case, first you have to find 360 by theta. Theta is in degree. If n is an even number, in that case only you can apply this method. Must remember this point. 360 by theta is an even number. In that case only you can apply this method. So when n is an even number, in that case you will get number of image charges. Number of image charges will be n minus 1. Number of image charges will be n minus 1. So let us take different angle. Let us take theta in degree. Then you have to write n, and then you have to see number of image charges. How many image charge will develop? So let us first see theta is, you have 15 degree. What will be n? N is 24. So n is an even number. When this angle is 15 degree, how many image charge will develop? 23. When this is 30 degree, this will be 12. How many image charge will develop? 11. When 45 degree, so that is 9.
8.
This is 8. So 7 image charge will develop. If it is 60 degree, 5 image charge will develop. Let us see 90 degree. I have discussed this will be 4, image charge will be 3. Previous example, angle is 90 degree. So image charge will be 3. So similarly, you can see for when it is 180 degree corresponding to 1 charge, you will get 180 degree 2. So you will get 1 image charge only. If you have, let's say this is 75 degree. How many image charge will develop? N is not even number. In that case, you cannot use this method. So normally in objective question, they will ask you this general case for different angle, how many image charge will develop. And when N is not even, you cannot use method of image problem. Is it clear?